Some equations that are not quadratics can be treated like a quadratic if we make a substitution. These are equations that are quadratic in form. For example, the equation x to the fourth minus 13x squared plus 36 equals 0. If we think of this as x squared squared minus 13x squared plus 36 equals 0, we might notice that it looks more like a quadratic. And if we make a substitution and we let some variable, we usually use u, equal x squared, then this might look like u squared minus 13u plus 36 equals 0. So this looks something more like what we're used to. Well, this will factor, looking for two numbers that multiply to 36 and add to negative 13. We will get negative 9 and negative 4 for answers u equals 9 and u equals 4. But remember that these are u values. So I need to go back to our substitution and say 9 is equal to x squared. Therefore, x equals plus or minus 3. Or 4 is equal to x squared, which gives us x equals plus or minus 2. So I actually get 4 answers here, positive 3, negative 3, positive 2, and negative 2. For another example, let's take a look at x squared minus 4x squared minus 17 times x squared minus 4x plus 60 equals 0. I'm hoping that you see that this expression x squared minus 4x appears here at the beginning and also in the middle. So we're going to substitute u for x squared minus 4x and rewrite this as u squared minus 17u plus 60 equals 0. So this polynomial also factors. If we're looking for two things that multiply to 60, we might make ourselves a list. And we might notice right here that if I had a minus 5 and a minus 12, they would multiply to positive 60 and add to negative 17. So we'll factor this as u minus 5, u minus 12, giving us u equals positive 5 and u equals positive 12. Well, again, and it's a good idea to always write this step in, because we can go back and say, well, what was u? And we'll plug this 5 back in. 5 equals x squared minus 4x. This will give us a new quadratic, x squared minus 4x minus 5 equals 0. And here, if we do 12 equals x squared minus 4x, we'll get a new quadratic, x squared minus 4x minus 12 equals 0. And we will factor each of these. Two things that multiply to negative 5 and add to negative 4 would be negative 5 and positive 1, giving us a final answer of x equals 5 and x equals negative 1. And for our second part, two things that multiply to negative 12 that add to negative 4, we might get minus 6 and plus 2 for a final answer of x equals 6 and x equals minus 2. So we have 2 answers here and an additional 2 answers here. So for the last 2 examples, you've noticed that we've gotten 4 answers. That is not always the case, but in this case, if you look here at the beginning, if we had multiplied this out, we would have had an x to the 4th power, and that's a good clue that we might get 4 answers. For the last example, I'd like to take a look at x to the 2/3 minus 3x to the 1/3 plus 2 equals 0. And I'm going to rewrite this so that hopefully you can see what our substitution should be. So, instead of writing x to the 2/3, I've written it as x to the 1/3 quantity squared. So you can notice that x to the 1/3 is part of the first term, and it's also part of the second term. So I am going to let u equal x to the 1/3 power. So we're going to have u squared minus 3u plus 2 equals 0. And if we're lucky, this will factor. I'm looking for 2 things that multiply to positive 2 and add to negative 3. So that must be minus 1 times minus 2. And we will get u equals 1 and u equals 2. Again, these are just u values, so we need to go back to our substitution and say 1 equals x to the 1/3 or 2 equals x to the 1/3. Now, it might take a little thought, but remember that x to the 1/3 is the cube root of x. So to solve this, we will cube both sides of the equation and get x equals 1. And same thing here, the cube root of x. And if I cube both sides on this one, I will get 8 equals x. And here we get 2 answers, x equals 8 and x equals minus 1. So in general, what we want to do with this kind of problem is make a substitution so that things are easier to look at. Once we do that, we can solve that equation, but remember, we must always resubstitute. I hope that helped. Thank you. Have a nice day.